Hello. It's time for more video. Chapter 6, mid-chapter review. Here we go. We're going to go through all 10 of the questions. Solving systems of equations is what we're doing here. We're going to use substitution. We're going to use elimination. I'm requiring everyone to write their work out to get credit during the assessment. So I'm going to be showing you how to do work on all these. There's a few word problems in here too. And we're going to do everything. We're going to get them all done. So let's jump right in. All right, number 1. Now, I'm going to tell you in advance right now, number 1 and number 2, the first two problems of the test are, they say use substitution. You really should use substitution. The problems are set up perfectly to use substitution. You'll see it's substitution whenever you have x or y by itself, like x equals 2y plus 9, or y equals this and that, you know, one of those types of situations. So that's how you know it's a good idea to use substitution. These problems are already telling you it's a good idea to use substitution, so let's do it. So here's what I'm going to do. I guess I could write the problem down, but I don't want to. I'm going to start by just writing the second line. So the second line was 4x plus 3y, but I'm not going to write x. I'm going to take the x out and write 4 times 2y plus 9 plus 3y equals -8. So the whole point of substitution is this. If you have x or y equaling some phrase, in this case 2y plus 9, you're allowed to take out x in the next equation, I'm trying to cover it up here, and completely replace it. So what I've done is, instead of writing 4x plus 3y equals that, I wrote 4 times all that stuff that x was equal to, plus 3y equals 8. Oh, so sorry. I'm coughing for 2 reasons. Number 1, I've been a little sick for like a long time. And number 2, I made some Chex Mix today, and I'm not going to lie, I made it really spicy to the point where like the fumes are lingering in my house and it's painful to breathe. So spoiler alert, if anyone wants to eat some really spicy Chex Mix, I'll probably bring some to school, but be warned, it's not a joke. Okay, so I distributed. I got 8y plus 36 plus 3y equals 8. There's like terms here. We got 8y and 3y, which makes 11y. Okay, we're gonna be having fun with this pen all day, by the way. Okay, plus, oops. Oh, I do want to undo. I want it to undo, and it won't. And I want it to do, and it won't. Undo? Undo? No. Fine. Just use one hand on the keyboard. Plus 36 equals -8. Okay. Minus 36 on both sides, which will leave me with 11y equals -44. I divide by 11, and the result is that y equals -4. So let me recap the steps here. First, we substituted. We took x out and turned it into the stuff x equals. Then we distributed, combined like terms, moved some things around. We got y by itself, so y equals -4. So if you want to go back and find x, you go back and use the first equation again. So the first equation was x equals 2y plus 9. So what I'm going to do is x equals 2 oh my goodness. This is just terrible. So x equals 2 times -4 plus 9. So that means x equals, you get a calculator out, it's fine. It's -8 plus 9, which is 1. So go back in and plug it in. You're going to be doing a lot of plugging it back in on all these problems. So 1, comma, -4. Now, all the work you just saw is what I'd expect to see as work for your assessment, okay? Now, if you want to be sure you're right, being right is definitely worth some points, but it's not everything. If you want to be sure you're right, you could graph it on Desmos, or any graphing calculator, I guess. And they meet at 1, -4, so they tell you the x value and the y value. This is, if you want to put it on the test and get it right this way, fine. But be warned, the work is most of the credit. Like, almost all the credit is from work, so you got to do your work. But if you want to know that you have the right answer, this is it, and also can guide you the right way. Let's say you worked out the problem and you got -1 instead of 1, but what you're doing is you're seeing this answer here and you're going, well, why is it 1? I got -1. So maybe you can go back into your work and make an adjustment. Maybe you forgot to make this -44, or maybe you divided it, you forgot to call it -4 or something. So you can graph it on Desmos or use a device to help you see the answer, but you should definitely use the just to check to make sure you're doing it right, you have the right work. There's no reason to, at the end of the day, put the wrong answer into the answer document or online or whatever. Okay, here's another one. This time we got y by itself. So I'm going to write the second line again. 5x plus 4 times 2x plus 1. Notice I'm taking the y out and turning it into the stuff y equals. Now, on both of mine, the thing on the top was the thing we substituted. That's not always going to be the case. The equations could go in either order. So I get 5x plus 8x plus 4 equals 17. Okay, we got 5x and 8x, which makes 13x. Minus 4 on both sides. 13x equals 13. Divide by 13. X equals 1. There's half the answer. Go back and plug it in. I'm going to use the top equation, the y equals 2x. Whoops. I'm going to write x. I'm going to write the number I got for x. 2 times 1 plus 1. So y equals 3. If you skip the intermediate step of doing 2 times 1 and just go right to 3, that's totally fine. I don't mind that. 1 and 3. Again, if you want to graph it on the device just to make sure you're going to get it right, like this, at the end of the day, this tells you if you're going to get it right. So I got 1 and 3. This says 1 and 3. See? Again, don't use it to get the answer. Just use it to make sure you're doing it right, okay? All right, number 3. This one's a little different. We're still doing substitution. It doesn't say you have to use substitution, but it's a very good method to use substitution. So here's the... I'm going to write this with colors and hope the colors make some kind of sense. On those previous problems, whenever y or x equals something, we're allowed to substitute it. So by that logic, if... Let's use the bottom one, for example. Y equals 9x. Doesn't that mean I can take 9x and replace y with it? So instead of writing y equals 3x plus 4, I could write 9x equals 3x plus 4. Now your problem could be 9x plus 2 or 3x plus 4 equals 7x minus 6 or something like that. They don't necessarily... Oh my goodness. I'm so sorry, the fumes are coming in the room. Uh-oh. Pause. All right. Woo. All right, so we're going to do something about the x's on both sides. That's what you want to do. If you have it, if you set up an equation that has x on both sides, you have to get rid of them off of one side. So I'm going to minus 3x. That's how you get rid of it completely. And you'll get 6x. And then I'll go back and fix my problem because it's got 24 the whole time. Dodoy, not just 4. Sorry. Now, the reason why I stopped and noticed that is because I was thinking 4 divided by 6 is going to be a fraction, and that doesn't usually tend to be the answers, although they do leave these boxes here as if to say these could be the answer. Alex has not usually been given us decimal answers on most of the problems. All right, anyways, I figured that's 4. Whoops. Whoops. Imagine being able to write a 4, huh? All right, there we go. Okay, you're not done. You got to go back and plug it in. You can plug it into the first one, like 4 times 3 plus 24, or you can plug it into the second one, which is 9x. I honestly think that one's easier. So y equals 9 times 4. Y equals 36. Boop. Okay, so it was substitution. It was weirder because it had y equals and y equals. That can happen. Also, we had a pretty big number for y, but that's going to be right here, so don't worry. Okay, so there's going to be one like that. Number 3, guaranteed on the test, 100% a substitution problem, well, should use substitution, where you have y equals this and y equals that. And then you should set them equal to each other and work it out, okay? Now, following that, there's a word problem. And the word problem we're about to do is structured just like the one we just had, y equals this and y equals that. Now, here's the deal. They don't tell you y equals this and y equals that. They just tell you a bunch of information, and you need to figure out what it's all about, right? So it says the sugar sweet company will choose from 2 places to transport sugar. So option 1, I'm going to write y equals. What is the cost? That's y. So the cost of the first company is 5,443 plus $200.75 per each ton. For each ton. When it says for each ton or per or for every or something like that, you have to put like X with it, okay? And then the second company charges 6,500 plus 125, 25X. You'll notice the second one has a higher initial cost, but a lower amount that they charge per. So what ends up happening is at some point they'll meet each other because one starts costing more but gains less over time compared to the first one. Okay, now this one says 2 questions. For what amount of sugar do the 2 companies charge the same? So this is just like the last one. Y equals this, y equals that. Let me draw the arrows and everything. Should I do it in blue again? Yeah, I'll do it in blue. Why not? I'm saying if all this stuff right here is equal to y, then it's fair game to replace y up there with this. And yes, I know I'm about to replace a lot of stuff with a lot of stuff. Okay, hold on a minute. Imagine having any control here. Okay, here we go. So 6, 5, 0, 0, 125, 25x, 5, 4, 4, 3, 275x. Okay, just like the previous problem, we have x on both sides. I'm going to remove the 125. It's the lesser of the 2 x values, so it seems like the thing to take away. So what I get left with is 6,500 on the left. Oops. That equals 5,443 plus 200 minus 125 is $75.50 x. 75 cents and 25 cents. Okay, now we work it out from here. Now, we didn't have this on the last problem. I mean, you could have, maybe. Could be on your number 3. But mine has some numbers on both sides, 6,500 and 5,443. So I'm going to minus the 5,443 because my goal is to solve for x, so I want to get x alone. So I'm going to subtract that. That leaves me with 1,057. Ah! I had a visitor. She left. Visitor, come back and shut my door. Alright, I gotta figure out what 1,057 divided by 7,550 is. This is definitely something you should use Desmo for. If it's a simple calculation, you should do it. 14! Now, there's no guarantee your answer needs to be a whole number, but I get the feeling that on this problem type, you're very frequently going to see a whole number. Oh my gosh, they opened that door, and my Chex Mix air came in, and it was very spicy. So x equals 14. E. Okay, so all that work was to find x. Well, what is x? Well, x is the number of tons I plug in for x so that the 2 companies charge the same. That's exactly what they asked for. What amount of sugar do the 2 companies charge the same? 14 tons. There's a second question. What is the cost of the 2 companies when they charge the same? Because 14 tons is how many you take, but what is it? What do you pay each company at that point in time? Like, what is the cost is going to be the same number for either company, but what is that cost? So you're going to plug in 14 to one of these 2 equations. I'll use the bottom one on account that it's mostly visible on the screen presently if I do it like this. So y equals 6,500 plus 125 times 14. So plug that in the old calculator. 6,500 plus 125 times 14. Okay, 8253.5. I'll write it down just to be thorough. 8253.5. So that's money. 835. No, 253.50. All right. I hope this is right. Woohoo! All right, so see, I got a decimal on that one. Decimal was good. All right, so word problem. Yeah. You know, okay, I'm going to be honest about the word problems. There's two things that make them harder in general. Number one, you have to make the equations. So I'm telling you on number 4, the structure of the equations on this one is you want to put it in a type of slope-intercept form. Y equals some number plus another number with x. That's it. That's how you set it up. The cost of the company, Y, is this much money plus this much per ton. Cost of the other company, Y, is this much money and this much per ton. Then you set those things equal to each other, technically by substituting, and then you work it out and you get 14, and then I plug it back in and I get this. So it's number 1, you got to make the equation. Number 2, it's only hard because there's decimals in it, but decimals, if there's decimals, just, you know, you use a calculator appropriately, and decimals really shouldn't be an issue. So, I mean, you can calculate. All right, next one. 2x plus 5y equals negative 6. Negative 2x plus 3y equals 22. Now, on these problems, these are adding or subtracting things together. These are not substitution. These are elimination. Because, well, for two reasons. On substitution, you're really trying to use that when you have x or y by itself. And on none of these, x or y are by itself. And you're also having them like super nicely lined up in quote-unquote standard form. So it's pretty much set up right for elimination. What's even better is the negative 2x here and the positive 2x there can cancel out with each other. So we literally add the equations together. Negative 2 and 2 make nothing. 5y and 3y make 8y. 6 and 22, well, it's a negative 6, and a 22 makes 16. You divide by 8 on both sides, and you get y equals 2. This is why elimination is so good, because when you could do elimination, very quickly gets to the first answer. Now the problem is, you got to go find the second answer, and you have to plug it in to find out. So I'm going to use the first equation. 2x plus 5 times 2 equals negative 6. 2x plus 10 equals negative 6. I minus 10 on both sides. 2x equals negative 16. Divide by 2, and x equals negative 8. So make sure you put it in the right order. I did see people doing their review assignment today that were just unfortunately entering stuff in the wrong order. Like they'd get 2 and put it as x and get negative 8 and put it as y. That's incorrect. Okay, again, I'm not saying you should do this. Definitely don't do this to solve the problem. But if you want to make sure you have the right answer, type it in. There were plenty of points today during class. I was helping students, and well, not plenty of times, but maybe 2 or 3 times where I got an answer, and I was like not working out, and I'm like, why is this not working out? So we graphed it. I saw what the answer should be, and I went, oh, forgot to put this sign here or something. So negative 8, 2. So negative 8x, 2 for y, okay? Again, you need to show all this work, the stuff canceling out, 5y and 3y, making 8y. You get the answer 2. I need to see that you plugged it back in. I'm seeing a lot of people not do the plugging back in part. I know it's pretty easy just to use a calculator to find it, but I really need to see what's happening here, okay? Let's take a look at another one. Okay, I want to show you one thing real quick because some people might get this on 5. This is not the problem, okay? I'm going to write EX for extra example, okay? So let's say you have 3x plus 2y equals 8, and you have 3x minus 5y equals 1. Okay, so let's say you're trying to work this one out. There's 3x and 3x. On the problem I had a second ago, I had two numbers, 2x and negative 2x that canceled out. 3x and 3x do not cancel out. So what you would have to do in this situation, because this could happen on your number 5, is you might need to make this a negative, make this a positive, and make this a negative. Like, the cost is you have to flip all the signs in the whole equation. Technically speaking, you're multiplying the whole bottom row by negative 1. That's what you're doing when you flip all the signs. But now that they're flipped, stuff will cancel out. The 5y and the 2y can become 7y, and the 8 minus 1 can become 7, and blah, blah, blah. You get all the answers. Okay, I'm just showing you that because that could happen on your number 5 question. spoiler alert, if you're watching this, thank you. The number 5 question should be something that you can cancel out immediately, or maybe you just have to flip the signs before you cancel out. Okay? On 6, and I think 7, maybe even 8, you're supposed to multiply one or more of the equations to be able to solve it. So going to my number 6 here, we've got 8x minus 3y equals 8. Negative 7x plus 2y equals negative 2. So here's the deal. Last problem, I had stuff that canceled out, like 2 and negative 2. And then on my little medium example there, I made it 3 and negative 3. There's not opposite numbers here. We have 8 and 7. No, that doesn't cancel. And 3 and 2, and that doesn't cancel, right? So what you're going to have to do on these ones is multiply one or more of the equations. First, check this. Always check to see if the smaller number for each variable goes into the bigger. Like, can 7 be multiplied to make 8? Not with the whole number. Can 2 multiply to make 3? Not with the whole number. So if that's the case, one of them does go into make the other one, I would just multiply one line because that's less work. But here, I'm going to have to multiply 2 lines. Might as well show you one with the maximum work, right? So here's the deal. You decide. Do you want to get rid of the x's or the y's? Do I want to make 8 and 7 the same number? Or do I want to make 3 and 2 the same number? There's a lot of people that like getting rid of the x's first, maybe because it's just easy to think about what the first two things can become. But in this case, it's 56, and 56 requires me to multiply by 7 and 8, and that'll give me some pretty big numbers. I don't know if I like that. I much prefer to turn 3y and 2y into 6y. So I'm going to choose 2 and 3. So 2 times 3 makes negative 6, and 3 times 2 makes regular 6. So that is going to work out when I multiply. You have to think ahead. Here's the deal, though. Make sure they have opposite signs. Like right now, the negative 3 and the 2, as they were, are already opposite y values, so I did not need to alter any of it, but sometimes you might need to multiply the whole row by a negative 3 or 2 or 7 or whatever you're using, so that stuff is opposite in sign. All right, the first row is going to become 16x minus 6y equals 16. Lots of 6 in there. Negative 21x plus 6y equals negative 6. Okay. Add them together. The y's cancel out. Let me just get that now. 16 minus 21 is negative 5x. 6 minus 16 is 10. Divided by negative 5 on both sides, and I get x equals negative 2. Okay, so now that I know that x equals negative... Hold on, that was kind of gross. Now that I know that x equals negative 2... I'm just going to leave it. X is negative 2, so I'm going to plug that in. I can plug it into the 2 new equations I made, or one of the 2 original ones. I'm going to use the first one. So 8x... Hold on, let me scoot this up. I was trying to scoot it down, but instead I got... Oh, you know what? I might like it like that, so I can see a little Desmos in the background. All right, so anyways, I get 8x, so 8 times negative 2, minus 3y equals 8. Negative 16 minus 3y equals 8. Add 16 to both sides. Negative 3y equals 24. Divide by negative 3 on both sides, and y equals negative 8. Good thing I moved my face cam for this video. My face is usually covering the bottom, right? I thought before I started the video, alright, this is going to be a smart idea because my face won't be covering up the thing like it usually is. Again, before you hit submit or enter or whatever you're going to hit on the test, this is all fair game for typing in if you want to make sure you're right. Is negative 2, negative 8 the correct answer? I don't know. 8x minus 3y equals 8. Negative 7x plus 2y equals negative 2. Sure enough, they meet at negative 2, negative 8. So you can confirm the answer is right. And then all this beautiful stuff you wrote on a piece of paper will make me say, dang, I'm going to give you full points because you know what you're doing. All right, another system of equations. Do the whole thing. We did the word problems the other day. I very much skipped around. This time, I'm going to do them all. If I'm going to ask you to do them all, I got to be willing to do them all. I'm trying to keep my time in mind, too. If I do it in under 50 minutes, That means I know what to... it wasn't a bad assignment for you guys. Not to mention I'm explaining my work. Okay, same situation as before. I would really like to multiply one row, but unfortunately I can't turn 3 into 8, and I can't turn negative 3y into 5y, which is a bummer. So now I get a choice. Do I want to get rid of the x's or the y's? Last problem I got rid of y's. This one I'll get rid of x. I think the y's look pretty good to cancel, but we'll do this. Top row by 8, bottom row by 3. I keep doing this thing where the number we multiply by is the number that was corresponding in the other row. That's not always supposed to be like that. Like, let's say you wanted to get 6 and 4 to the same number. Well, 6 times 4 is 24, but you could also make 6 and 4 both go into 12. There's nothing 3 and 8 go into besides 24, so I gotta do that one just like this. Unfortunate. Okay, 24x minus 40y equals 8 times 23, which I believe is 184. Then I get 24x. Now this is where you should stop for a second and say, uh-oh. Didn't I want x's to cancel out? Shouldn't I have made it so that something is opposite? Okay, let's fix our boo-boo. Negative 3. Now that'll make negative 24x. We got to make sure these are opposite, because I'd rather just add them together, and the only way to add them together and cancel stuff out is if they're opposite signs, so I had to go back and change it to a negative 3 to fix it. So negative 24x plus 9y, oops, okay, equals negative 60. Bigger numbers here. Add stuff together. These cancel out. You get negative 31y. Oops. And over here you get 124. Might be a little daunting at first and make you wonder, does the number really go in? I'm hoping for a whole number, right? Sure does. Makes negative 4. Okay, pen. Don't do that to me. Here, I'll type that now. Negative 4. There's a y value. Okay, we got to go back and find x. So I'm going to plug it into one of the originals. So I'll use the top row original. So 3x minus 5 times negative 4 in place of y equals 23. 3x plus 20 equals 23. And minus 20 on both sides. And I get 3x equals 3. Should be a pretty obvious answer, I hope. 3 divides each side to find that x equals 1. You gotta show me the work. You gotta show me that you're multiplying both equations. You gotta show me you canceling out to solve for one of the variables, and you gotta show me plugging it back in and working it out for the other one. And I'll, of course, check on Desmos if you want. I'm trusting my answers here. Woo! Okay, here we go. More stuff. These ones are pretty easy. Now here's the deal. These are set up a little bit different, but you should treat these like any other problem. Like, write it down. I mean, I want to see the work. A lot of people did this in class without writing it down, and good, I guess, but I really need to see what you're doing. So first thing first, I want to add these together, but I can't unless they're opposite. So I'm going to make this negative, and that negative. It's like I multiplied the whole bottom row by negative 1. And 2x and negative 2x cancel out. And 5y and negative 5y cancel out. So people have been asking, like, what happens? You got to write something. If everything cancels out on this side, this whole side's value is essentially 0. Like, if it's all canceled, it's 0. Okay, then the other side is 6 and negative 5, which makes 1. Now, there's two situations you get here. When the letters all go away, you either have a true statement or a false statement. And when it comes to these problems, I'm noticing you tend to get 0 on the left side if it happens. So 0 equals 0 is good. That's all solutions, like infinitely many. But in my case, I got 0 equals 1, which is not true. 0 does not equal 1, believe it or not. So that system has no solution. Okay? A unique solution would be if you worked it out and some letters stayed and you actually could solve it and answer it and get an, let's say you work it out and you get y is 2 and x is 1. You put in 1 comma 2 and call it a day, right? In this case, it's no solution. 0 does not equal 1. Just in case students were wondering, doing 0 homework is not the same as doing 1 homework. Oh, I'm just so clever. All right, anyways, next. So y equals 6x, y equals 1. I think what's happening, 1x. I think what's happening on problems like this is people are looking at it and it looks weird because, you know, we're used to seeing maybe a little bit more equation or something. This is it. This is just like a much earlier problem. If y equals x, then isn't it fair game to substitute x into the equation? So instead of y equaling 6x, we could write x equals 6x. Now, this is a weird situation. How is it possible, and what number is it possible for, such that the number itself equals 6 times the number itself? What number in the universe, when you multiply it by 6, makes the same number? Well, I don't know. Well, I do know, but I don't want to tell you. I'll tell you what you need to do, though, is you need to minus x on both sides. Because as usual, if you have x on both sides, you got to get rid of it. But you're probably thinking to yourself, well, it's gone. What do I write? Just like the last one, write 0 and 5x. 0 is 5x. Divide by 5. 0 equals x. So what that means is this. It's not a special answer. It's not no solution. It's not infinitely many solutions. It is a unique solution, and it's 0, comma, well, you gotta plug it in and see what you get. I hope it's very obvious, though. I'll use the top one just to illustrate it. Y equals 6 times 0, and 6 times 0 is 0. If I'd plugged it into the second one, it would have just said y equals 0, and I would have been like, oh, okay, that's the answer. So it's 0, comma 0. In fact, I don't want to graph it, but if you were to graph these two things on a graph, you would see them crossing at 0, comma 0, okay? If you graph something with no solution, you would see two parallel lines, and if you see something with infinitely many solutions, you would see two lines that are on top of each other. Now, we're not really supposed to know that yet because that was from the first lesson, but we skipped that one because we're going to get back to it and do it and stuff. I'm just telling you that if you're using a graph to help you work your way through the problem. That's that. All right, next one, we got word problem. I saw a lot of people ask about this one today. The key is the setup. If you can set it up, I'm sure you can solve it. So here's the setup. The sum of two numbers is 36. I've seen so many of these now, and I'm 100% sure that every single one of them starts with the first sentence, the sum of this and that is some number. So a number I don't know, x, plus a number I don't know, y, is 36, because it says the sum. Now the second equation varies. I've seen it say the difference is 12 or something. Like, so I'd write another line going x minus y is 12. I've seen it say the second number is 10 more than the first number. So you'd write y equals x plus 10, because that makes one number is the other number, but 10 more. My problem says the third option. One number is 2 times as large as the other number. So one number is the other number times 2. Now, the way you solve these varies. Like, if it was a difference problem, I would use elimination. If it was a this much more or this much less, or in this case, the multiplied amount, I'd substitute. Y is equal to 2x, so isn't it fair game if I replace y and rewrite the line as x plus 2x equals 36? Combine like terms, 3x equals 36. Divide by 3, x equals 12. Now here's the deal. If you're not sure if 12 is the bigger number or the smaller number, just hold it on the paper and write it at the end. You can plug in 12 to either equation to find the other number, but I'm going to use the second one because that is easier. Y equals 2 times 12. Y equals 24. And then you can check. Does it follow the rules? Like, think about it. Is the sum of these two numbers I just got 36? Yes. Is one number 2 times as large as the other number? Yes. You could technically guess and check your way to the answer at worst, but here's the deal. You really need to, like, show me some work. Don't show me you guessing and checking. That doesn't work. All right, last one. How's my time looking? 33? I think 33. Well, it's going to be like, what, 35, 38 minutes? I think that's pretty good considering I'm explaining myself. All right, last one. It is a word problem. A rental company has chairs to rent. I've seen chairs rental. I've seen box sizes. I've seen people renting movies and video games or something like that from the rental store, even though that's totally not really applicable in 2019. But whatever. So there's 2 chairs and 6 tables. I don't know what the cost per chair and the cost per table is, but I do know if I buy 2 chairs, that's like 2x. There's 2 chairs times however much they cost, plus 6y, 6 tables, and however much those cost, ends up equaling $52 I got to pay. Then on the second sentence, it says the total cost of 5 chairs. All right, come on, pen. Don't do me like this now. And 3y equals 31. So I'm setting up two equations. These are a little different. A much earlier word problem had me write y equals this and y equals that. This one had x and y on the same side because this is referring to two different kinds of things contributing to a cost. The earlier problem had to do with like a fixed cost plus some extra stuff. So it only had x on one side and y on the other side. Anyways, we have a situation here. I can't combine to make stuff cancel out. I can't turn 2 into 5, but I can turn 3 into 6. Now this is why I've been checking to see if the smaller number makes the bigger, because I don't want to multiply both equations if I can help it. Like I could multiply the top row by 5 and the bottom row by 2 to make 10, but wouldn't it be just so much easier if I just had to do only one step by multiplying by -2? So here's the deal. I'm going to rewrite the top row here. 2x plus 6y equals 52. -10x minus 6y equals -62. Uh-oh, I heard my timer go off in the other room. My Chex Mix needs to be mixed. I'll mix it in a second. Actually, you know what? I'll mute this and just tell somebody what to do real quick, okay? Hold on. Okay, instructions were given. Alright, so anyways, I get -8x. This stuff cancels, and this stuff equals -10. Now, I'm going to divide by -8, and then this is where I'm going to give a slight warning. Now, almost none of the problems so far. Wait, was there even a problem that had this? None of the problems so far had any decimal answers, but -10 -10 divided by -8 is 1.25. That is fair game, I feel like, in these problems, because the cost to rent chairs and tables could be something with, you know, a decimal. But what did I just find? I found $1.25, I guess, but what's that the cost of? Well, I had been using x to replace chair, like 2x, 5x. Those are the chairs. So when I find x, I'm finding the cost of a chair, $1.25. Okay? I still need to go back and find y. So let me use an equation here. I'll use the first one, 2x, although I'm going to turn the x into that. Wow, okay, hold on. That's pretty disgusting. Let me write it pretty. Am I okay? 2x plus 6y equals 52. So this becomes $2.50 plus 6y equals 52. I minus $2.50. 6y equals 49.50 divide by 6. 49.50 divides by 6 to give me y equals it's calculator time, you know. $8.25. All right, they don't have to both end in 25, but sure, if it does, it does. Here, I'll write 8.25. So there's my work. I got x. This was the first thing I got. And I plugged it in. And I worked it all down to here. Oh, snap. Whoop. And then I got that to find the y value. Okay. We will recap real quick just to make sure we are good on this one. Let me hit submit assignment. I want to make sure you got this. These problems on here. Hey, I got to take a knowledge check. Oh, darn. No, I'm just kidding. I won't. Hey, look, 37:59, just before 38 minutes. All right, so here's the deal. I'm just going to run through. The first two problems guaranteed are substitution. They don't have to be substitution, but they strongly encourage it, and I strongly recommend you do it. So first two substitution problems. Problem 3. It has y equals this and y equals that. Also a substitution problem, just set up in a slightly different way. So what I would do is set the x stuff equal to the other x stuff and work it out. Refer to the video. Problem 4 is just like problem 3, except for it's a word problem. We had to make the equations. Y equals this, y equals that, set the companies equal to each other, blah, blah, blah. Then you go back and plug the value in to get the cost at the same time. Sorry. Number 5 is an elimination problem where you are either going to have two things like me, like my two x's are just ready to go and eliminate, or maybe you might have to switch some signs to opposites on the whole equation before you eliminate. That's 5. 6 and 7 are both going to be elimination systems you might have to multiply one line, you might have to multiply two line. On both of mine, I had to multiply both lines. But I think I saw some today where just the first line or second line only was required to multiply. No idea. Number 8 is one of these special ones that will very likely, wink, include at least one answer that's no solution or infinitely many solutions, and very likely include a legitimate unique solution answer. Mine was 0, 0. Yours doesn't necessarily have to be 0, 0. I saw plenty of problems people did on here that were just like any other regular problem, okay? But I do feel like you will see one that's either no solution or infinite solutions. Number 9 was a problem that described two numbers, and I set up some equations. So x plus y is 36, and my other one was 2 times larger, so y equals 2x. That's how I did the other one. And then number 10 was another word problem talking about two different kinds of costs, and I set that up. I multiplied just one line. That's all I needed to do. And I plugged it in, blah, blah, blah. I got some decimals, but that can happen. And that's it. Want to save? Nope. All right, so yeah, that's the dealio there. 10 questions. I hope they go. I mean, I did about 40 minutes here with a whole bunch of explaining. So hopefully that's about the time it takes you to do it. All right, I'm gonna go tend to my Chex Mix. This thing the air is spicy in my house right now. I'm gonna start watering in the eyes. If anyone eats that tomorrow, or whatever, I'm sorry. But I'm telling you now, if you want to eat the Chex Mix, you gotta promise you're not gonna go crying, because it's gonna be a hot Chex Mix. All right, and good luck on the assignment. Write notes down. You can bring them in. So if you're doing your problem 1 through 10, write them down. Heck, you could, if you watch this video, good on you. You could write down all the notes I just wrote down for my 1 through 10 and have an additional set of notes. Or if you thought yours were not as good, write down what I just wrote down. I did them all out for you. So I know it takes time, but it'll be worth it. Okay, you put in the time, you get the reward. You know what I mean? Okay, that's all I got to say, and I hope you liked that video, and I will probably see you on another video in the future. See ya.